Hello friends, in number session today we'll be talking about how to find out the total number of factors and the sum of factors of a composite number and how to check for the prime numbers. So let's now see how do we find out the number of factors of a composite number. So what do we do is we first write the composite number that we're talking about as a product of prime numbers. So for example, we have a composite number n that can be written as a product of the prime numbers, a, b and c being the prime numbers. So we say a raised to power p, b raised to power q and c raised to power r and so on. So this is how we denote any composite number n. Now if this is the notation that the number of factors small n of this composite number capital N is given by n is equal to p plus 1 into q plus 1 into r plus 1 and so on. So if there are other factors like d raised to power s and so on, then we'll continue to add s plus 1 and so on to it. So we'll multiply 1 more than the power of each prime factor and then we'll get the total number of factors of the composite number. So now let's take an example first of all. So supposing we want to find out the total number of factors of 200. Now 200 can be represented as 2 raised to power 3 and multiplied by 5 raised to power 2. So the number of factors for 200 will be this 2 raised to power 3. So we have 3 plus 1 and it is 5 raised to power 2. So we have 2 plus 1. So we multiply 3 plus 1 with 2 plus 1, which is 4 multiplied by 3, giving us 12. So this is the total number of factors. Now let us see what are the 12 factors that 200 has. So the factors are 1, 2, 4, 5, 8, 10, 20, 25, 40, 45, 100 and 200. So these are all the factors which are 12 in number. So this is how we find out the total number of factors of a composite number, which includes the number itself and 1. So this formula is going to give us the total number of factors of the composite number. So let's now see how do we find out the sum of all the factors of the composite number. So now first we again write the number as a product of prime numbers as we did when we were finding out the total number of factors. So n, that is the composite number for which we want to find out the sum of all its factors, is equal to a raised to power p multiplied by b raised to power q multiplied by c raised to power r and so on, where a, b, c are the prime numbers. Now in this case, the sum of all the factors represented by Sn of the composite number n is given by Sn is equal to a raised to power p plus 1 minus 1 multiplied by b raised to power q plus 1 minus 1 multiplied by c raised to power r plus 1 minus 1 whole divided by a minus 1 into b minus 1 into c minus 1. So what we are saying here is that n is the product of a raised to power p multiplied by b raised to power q multiplied by c raised to power r. So the sum is a raised to power this power p plus 1 minus 1 into b raised to power q plus 1 minus 1 and c raised to power r plus 1 minus 1 and so on, divide by this all these prime numbers, subtracted 1 from them and then taking product of all of them, which is a minus 1 into b minus 1 into c minus 1 and so on. So the complete sum of all the factors of this composite number is given by this expression. Now again let's take the same example, 200. We know that 200 is represented by 2 raised to power 3 multiplied by 5 raised to power 2. So using this formula we get the sum is equal to 2 raised to power 3 plus 1 here, which is 2 raised to power 4 minus 1, and similarly 5 raised to power 3 minus 1 divide by, this is whole divide by 2 minus 1 and multiplied by 5 minus 1. So that gives us 2 raised to power 4 minus 1 is 15. 5 raised to power 3 minus 1 is 24. Divide by 1 multiplied by 4. So that gives us 15 into 31, which is 465. Now let's see if the sum of all its factors actually comes out to be 465. So the factors were all of these. Now if we add these factors, we get the sum to be 465. So this is a very useful formula to use when we want to find out the sum of all the factors of the given composite number. So why do we say that this is true only for composite number? Is quite obvious, because a prime number cannot be represented in this form. Prime number will only have itself as one as its factor. So finding the sum of its factors or finding the total number of factors is not required. The number of factors is always 2 for any prime number, and the sum of the factors will be the number itself plus 1. So we do this only for the composite numbers. So now let's look at how do we find out the product of all the factors of a composite number. Now we take the composite number as capital N, and the product of the composite number n, all the factors of this composite number n is always given by capital N raised to power small n by 2, where small n is the total number of factors of n, which we have just seen how to find out. Now if we know the total number of factors of n, now we can find out the product of all its factors. So let's take the same example again. We take 200 as a number. We know that it can be represented by 2 cube and multiplied by 5 square. So the number of factors is 12 that we've just calculated. So now let's see what is the product of all its factors. It is given by 200 raised to power small n, which is 12, divided by 2. So that gives us 200 raised to power 6 as the product of all its factors. Now let's see whether it actually comes out to be that or not. So we know that all the factors of 200 are these. Now if we want to find out the product of these factors, we can pair them up in set of 2. Like we take 1 and 200 and the product gives us 200. Similarly, we take 2 and 100, that gives us the product as 100. We take 4 and 50, the product gives us 200, and similarly we take other pairs. So we know that there will be pairs formed like this. So the number of factors is 12, the pairs formed would be 6, and hence the product of the factors is given by 200 raised to power n by 2. So not 200 actually, whatever the composite number is, which is capital N in this case, raised to power n by 2. Now the important thing to note here is we have taken a number whose factors are even numbers. What if the value of n, the small n, is odd? So what we are trying to say is that the total number of factors of this number, the composite number n, is odd. When is it possible? This is possible only and only if this condition is possible only if the composite number given to us is a perfect square. So if it is not a perfect square, if the given number is not a perfect square, then we know that this will always have even number of factors. It cannot have odd number of factors if it's a non-perfect square. In case of a perfect square, say for example we take 25. Now this can be just represented as square of 5. So the factors for this would become 1, 5 and 25, and if we use the formula for finding out the number of factors and the sum of factors, both of them are still applicable. But for finding the product of factors, this will not be applicable because we cannot pair them up. We can pair 1 and 25. We can pair these two numbers, but for 5 there is no pair because it was to be multiplied with itself. So we've taken it as 5 only once. So now in these cases, these are the only exceptions where n will be odd. So in these cases, the product would be given by, we'll say, capital N raised to power n, which was odd in this case, plus 1 divided by 2. So this gives us, in this case, we have number of factors as 3, so we add 1 to it, we get 4 divided by 2, so which gives us n raised to power 2, which is 25 square. Divide by the square root of the given composite number, which is the perfect square. Now this is a very important formula to use. We'll write it again. We say product is given by, and this is true only where we have capital N as a perfect square. So we are saying capital N raised to power small n plus 1 by 2 whole divided by the square root of n. So now let's see if we apply this to 25, what happens. We are saying it has 3 factors, so we have 25 raised to power 3 plus 1 4 divided by 2 divide by the square root of this perfect square, which is 5. So we get 25 into 5, which is the product of the given composite number. So this is true only for perfect squares. This is not true for any other number, for any other composite number. The formula remains n raised to power n by 2, because in that case the small n will always be an even number, but for the product of perfect square, this is the formula. So friends, now let's see how do we check whether a given number is prime or not. So we first take the number n and we find out the square root of this number. Now if this square root of this number is a natural number, then we know that it's a perfect square and hence it is not a prime number. But if its square root is not a natural number, then we just take the natural number which is just above this root and let's call it p. Now we divide the given number n by all the prime numbers which are less than p. So all the prime numbers which are less than p we will take and we'll divide n with that. Now if n is divisible by any of these, then it is of course a composite number, else it is a prime number. The important thing to notice, one is neither prime nor composite, so that is not to be considered for this division purpose. Let's take an example. Say for example, we want to check whether 241 is prime or not. Now the simpler approach, a standard approach is to check for all the prime numbers less than 241, but that is obviously a more time consuming approach. We should not be doing. So now we'll find out the square root of 241 is just above 15. Why? Because 15 square is 225 and the square of 16 is 256. So it lies between the square of 15 and 16. So we take 16 as the number and we check its divisibility of 241 with all the primes less than 16, which are 2, 3, 5, 7, 11 and 13. Now since this number is not divisible by any of these, so it is called a prime number. So instead of checking its divisibility with all the numbers, all the prime numbers till we reach 240 or till we reach half of this, it is much simpler approach to check for its divisibility in this way. And we know that 241 is not a prime number. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.